to raise awareness, appreciation and understanding of maths, and it's founded by Calmus, Waterford IT. And tonight we're lucky enough to have Kjartan Poskitt to talk to us. And I'll just tell you a little bit about our speaker. Kjartan's Murderous Maths books have sold well over 1 million copies worldwide. The book has been translated to 25 languages, and it's used in schools and homes throughout the world. Kjartan has also written over 50 other books, and he's presented many maths and science programs for BBC. And he also writes and delivers his maths shows to theatres and schools. In 2007, he was a judge for the Blue Peter book competition. This year, his latest novel, Urgum.
It sounds like an obituary. It's like he's dead and this is what he did. I'm still here.
I'll hand over to you in a minute. Actually, Urgum and the Goo Bar.
Yeah.
Is that right? Yeah. It's shortlisted for the prestigious Roald Dahl Funny Prize. And I think I'll hand over to you now, actually.
Oh, nice intro. I've got a thing here. I don't need a mic. I've got a thing to make me louder. What you'd really like is something to make me softer. Give it 10 minutes. Anyway, how lovely to see you people. I was here this time last year to see Rob Easterway do a talk, and I thought, what a lovely place to do a talk in. So I'm absolutely, I can't tell you how delighted I am to be invited to be here tonight. Well, it's rubbish, but I'll do my best. Right, yeah, I write the Murderous Maths books. Usually when I talk to people, I talk to kids aged, 10-year-old roughly. Tonight you're all a bit older, but I'm not going to compromise. Same stuff. The maths isn't terribly difficult. What I like to try and show people is that it's not just all graphs, pie charts and times tables. And my books are called Murderous Maths, and I'm trying to find my first prop. Oh, here we are. In fact, somebody put a couple of books on top. That's just a couple of the titles I've got. There's 16 of them, so yes, they do actually exist. It's not like a made-up thing. I'm going to quickly give this back to Paul before I nick him. Yeah, Paul, that's your book. Cheers, man. Right. The problem was the horrible history books about 15 years ago had started, and then the horrible science books, and I was asked to write a book called Murderous Maths. And I said the big problem about that is maths isn't murderous. I mean, in history, lots of people kill each other. In science, there's nasty experiments. Where's the murder in maths? And so I had to dig around a little bit and actually find murder. And it turns out that a lot of the old mathematicians were pretty unpleasant and could get quite competitive to the point of killing each other. So the first guy I want to talk about is Pythagoras. Yippee, I hear the cry. Don't worry, there's going to be no right-angled triangles, although actually that also led to a murder, but we're going to leave that one there. Pythagoras lived over 2,000 years ago. He was a massive star, the big celebrity of the day. He'd done the right-angled triangle thing. He did lots of other stuff. He worked out how music worked and things like that. Lots of things that not many people know about. But because he was such a big star, people like to try and catch him out and trick him, give him questions that he couldn't possibly answer. So what they did with Pythagoras was they gave him these paradoxes, and I'd like to do a paradox now, and I've just realised that I can do it without volunteers, or I can do it with 2 volunteers. Thank you, thank you. We'll do it with volunteers. It's let me first of all explain the game here. It's the paradox of the hare and the tortoise. The hare and the tortoise are going to have a race, and to keep the sum simple, we'll say that the hare runs twice as fast as the tortoise. So obviously the hare's going to win the race. But supposing the hare and the tortoise are going to have a race, but the tortoise starts slightly in front. The hare can run twice as fast. The hare's going to overtake the tortoise, yeah? If I'm driving in a car going at 100, are you miles per hour or kilometres in Ireland? I don't know. Look, I'm driving a car going at 100 something, and you're driving in a car that goes 50 something. If I'm behind you, I'm going to want to try and overtake you. But they said to Pythagoras, if they have a race and the tortoise starts in front, actually the hare will never ever catch the tortoise, even though he goes twice as fast. Now, of course, the hare catches the tortoise, but I'm going to demonstrate now the argument as to why the hare will never catch the tortoise. Have I actually got anybody who wants to volunteer? I need 2 people. I'll tell you who we're going to have. We're going to have Colette, because it was her idea. Round of applause for Colette here. She's just volunteered. Thank you so much, Colette.
I'm not very good at running.
And it's no running is required. And I think it's only fair. Put the video camera down. I think her husband should be the other volunteer, because it's thanks to him that I got here. Thank you. Owen and Colette. There we are. Now, what I'll ask you to do, Colette, could I ask you to go and stand by the lady with the pink jacket there, okay? Right then. Owen, can you stand about there, okay? Right, now, this is the paradox of the hare and the tortoise. Colette is going to play the part of the hare, nicely done hare, and because Owen looks a bit... Anyway, tortoise. What we're going to do, you're going to race towards the stage. But don't worry, it's not like a race, okay? We're going to do it in little movements. We're going to analyse it piece by piece. And I'm going to prove to you that even though the hare goes twice as fast as the tortoise, the hare can never actually catch the tortoise. Here we go. So to start off with, I'm going to move you one at a time. You stay there, Owen. Okay, if Colette the hare can come running up towards the tortoise. Now, in all their married time, that's the first time she's ever run towards him. He like that, okay? But no, Colette, you come stay there for me, darling. That was beautifully done. But you, about there, that's there. Owen, can I ask you to come to about there, mate? Right, now what's happened was, if this is a real race, and Colette is moving twice as fast as Owen, she's moved twice the distance, okay? So at this point, I could take a photograph, and that's actually where they would be, okay? She's moved twice the distance because she goes twice as fast. Now, once again, Colette, if you can come to here, please. You take about big step there. Once again, they've done the next bit. And because she's moving twice as fast, she's moved twice the distance, okay? Can you see where we're going with this? But the important bit is the gap in between them. Every time we do this, the gap in between them gets chopped in half. In fact, if you take like that one step forward, you take a half a step forward. Once again, we've chopped the gap in half. Right, for now, you two, thanks. Go and sit down. Round of applause for the volunteers there, everywhere. Thank you, Owen. The gap keeps getting chopped in half. But if you get something and keep chopping it in half ad infinitum, will it ever disappear? No. And that's the gap between the hare and the tortoise. The gap will keep getting chopped in half. If we kept doing that, the gap would never, ever completely disappear. That's why the hare can't catch the tortoise. This paradox defeated Pythagoras. He couldn't work out what was wrong with the argument. There is something wrong with it. It's a real toughie. Don't ask me to explain. But Pythagoras was so upset by this that the messenger that was sent to give him this puzzle, Pythagoras had the guy killed in probably a fairly brutal and public way to make sure that you don't ask questions like that. Okay, so there you go. So when I was asked to write Murderous Maths, I mean, even old Pythagoras, he was in on it. Now, I've got another one here, another example of Murderous Maths. The people that sort of like did a lot of algebra about 300 years ago lived in Italy. And very clever guys. One guy's name I can't remember, but I know he's only 23, and he got into a duel, he got into prison, he was killed in a duel age 23 and stuff. But in his sort of like death cell the night before, he scribbled 3 or 4 pages of stuff, and this is like landmark material in pure mathematics, you know, the night before he was executed. Could have gone on a rave or a club, but no, he did that. I'm going to show you what these guys, a lot of them, did for a living. Because they understood maths and numbers, they knew about probability, how about chance, dice and cards and things like that worked. And I'm going to show you the sort of thing that they probably did to make some easy money in a tavern. I need 2 more volunteers. I'm lucky now. The lady in the pink has been a particularly good audience member, so she's just volunteered, actually. But because you volunteered, you get, no. You get to pick anybody else you like in the audience. So there you go, you have power. Who would you like to pick to join you? You here. Thank you very much. 2 more very willing volunteers came up completely of their own accord. Let them come and join me on here, please. Thank you so much for coming up. Right then, can I ask your name?
Agnes.
I'm going to give you the easier job. We are going to take 37 euros off this guy, okay? What's your name?
Shane.
Not real money, Shane, don't panic. Okay, Agnes, if I can just ask you to sort of stand here, and Shane, if you can just sort of stand 1 step nearer to the board, in between Agnes and the board. Thank you. Right. What we're going to do is I'm going to start off by giving you some virtual money. Okay, Shane, we're not going to play real money because I want to leave this place in one piece, all right? I understand the way it works. So let me put, I'm going to start off with €100. When this trick finishes, I will have taken about, it might be one or two more, might be less, but I'll have taken about €37 off you. And the beautiful thing is, we're going to play a game, but it's a game that you can't possibly lose. That's the joy of it. Right, there's two rules. The first rule is you have to bet your money each time we play. And so you have to bet half your money. So you start with 100, half of 100 is 50. You are going to bet €50. And what are you betting on? I have a pack of cards here. Let's have a wee look at these cards. You're going to draw a card from the pack. If you pick a black card, that's a winner. If you pick a red card, that's a loser, okay? Black cards, winners, red cards, losers, yeah? Quite simple. Now, does that sound fair? A fair bet, yeah? Because in the normal pack of cards, there's the same number of red cards as black cards. And if you're not certain, have a look. Do it again, they'll clap next time. No, yeah, thank you, right. Right. I'll do that one. Now, and you've got to do this. Listen, I'll show you, there's a little trick to it, okay? I'll do it slowly, ready? We're not using these cards. They're on a string. Okay. Now, this is the whole point of it. It's a con. We're going to make it look better than that, because a 50-50 chance, if you came into a bar and it was a bit dark and there was an old guy there with a pack of cards, you'd think, what's the point? So I'm going to make it look attractive to you. 4 black cards, 3 red cards. These are the cards that we are going to be playing with. There are 4 winners. There are only 3 losers, okay? Now, I'm sitting there and you're a bit dubious about playing for money with me. And I say, I'll tell you what, son, I'll guarantee you can't lose. And so we shuffle the cards. If you picked a red card, you'd lose. And I'd feel awful about that. So there's 2 rules. One is you bet half your money every time. The second rule is we are going to play all 7 cards. You're guaranteed to win 4 times. You will only lose 3 times. It sounds attractive, but I know the sounds, okay? Your job is to make sure no one can cheat. So I've shuffled them up like that. You can shuffle them a wee bit more. And then if you hold them face down so nobody can see them, and so Sean can pick the cards one at a time. You do that with the cards for me, please. Let me just get the... Whoa. Let me just get the pens ready. There's a step there, you know. I've just noticed it myself. Right. Here, I love teaching kids in school this, because you can see all the teachers watching thinking, why am I teaching? I could be doing this for a living, you know, a few cards and making some money. Okay, here we go. Could you please pick the first card and let's see what you've got. You can pick any of the ones he's messing around with, or if it's a black card, you win, a red card, you lose. We play all 7 cards. Hold it up, let everybody see. What is it? Is that black or red? Black. Little chair. He's won. He's won. We're there. That sits there. Okay. Is that going to sit there? Can you hang on to these ones, actually, if it's going to fall off? Right. I'll do green. That means you've won. And we're on to 150. You bet half your money every time, so that's 75. Pick another card for me, please. Is it black or red? I can't see. Oh, another little chair. Yes, you're on the roll. We do play all 7 cards, though it is important to stress that at this point, because you're doing just a bit too well. Right, can we have the next card, please? Next time I go to the races, you're coming with me. I'll tell you, it's fantastic. Let me have a wee look here. We've got 3, 3, 8. Doesn't normally go this high. Right. That must be 1, 6, 9, I'm guessing. If my sums go wrong, do feel free to correct. Okay, next card, please. Got to lose, it's got to lose, it's got to lose, it's got to be red, it's got to be red, it's got to be red. Flipping Nora. That is, I've never had anybody actually pick 4 just like that before. You've got to come to Dublin for it to happen, haven't you? Right, hang on a minute, we're still playing all 7. Don't you sit down yet, son, I'll tell you. Right, let me do the sums, because that must be a 7. There's a 1 to carry. See, I'm out of my depth here. There's a 0 now. Is that really 507? It is 507. I've never got, nobody. I must have done this trick probably 100 times. Nobody has ever done that before. Talk about, look at the Irish. Right, get that in there. We probably know what's coming next, but we'll go through the preliminaries. It's 253. You've lost at last. Thank goodness for that. So we're back to 254. I'm doing it roughly. I'm not bothering with 50p's. Okay, half of 254 is 127. Okay, the next card better be red, otherwise I'm going to really panic. Yeah, thank goodness for that. We have a minus there. That means you've got 127 left. Half of 127 is about 64. I'll put a line under it there. Next red card, please. Hold it up. There we are, bang. And don't sit down yet. I'll just show you the numbers. 63. Right. As you can see, that was a fantastic freak result. You've got to come here to get it. But it wouldn't have mattered. It wouldn't have mattered. What I want you to notice is, he started with 100 euros. He's got 63 euros left. I've taken 37 euros out of his pocket. That is a freak. Congratulations, my friend. I think that's fantastic. Round of applause for my two little kids. Thank you, my darling. Thank you. Go back. Thanks for coming to join me when you were press-ganged into it. That's the end of the volunteer bit for a while there. You feeling relieved? Yeah, good. Okay. Right, let's pop these back into the bag. There's no big maths in that trip, by the way. All those sums I've done in front of you, apart from rounding off the odd 50 cents. There's no trickery. The numbers do all the work. It's the beauty of it. Right. I've just been writing a great big colour book, which I'm extremely proud of. This is a sample, a trade sample of it. And it's the Murderous Maths of everything. And it's, I don't know, I get into the really obscure stuff. I could have written an entire book just about chessboards. In fact, to me, the most boring thing you can probably do with a chessboard is play chess. I mean, there are so many weird mathematical things about a chessboard. If I can just give you one bizarre example, I wrote one book called Numbers, the Key to the Universe. And it has all the strange numbers listed that I could find information for. Oh, I've lost all my pens. Here we go. If I can just put one of these numbers up because it's rather fun. This number is associated with a chessboard. Somebody spent their entire life working that out, probably. Chessboard, it's got 64 squares, 8 by 8. I want you to imagine you have a box of 32 dominoes that are all double blank. Okay? 32 dominoes would be exactly the right number of dominoes to cover a chessboard, yeah? Now, just supposing for a minute you have a chessboard that's only 4 squares, like that. All of you, how many dominoes does it take to cover the chessboard? 2, thank you. You can either put them on like that, or you could put them on like that. You can't do that because it leaves gaps. So there's 2 ways to put 2 dominoes on the chessboard. Do you know how many different ways there are to put 32 dominoes on the chessboard? 12,988,816 different ways. I don't know who worked that out and they can't hear us, but nevertheless, they deserve a round of applause. Be honest. Isn't that fantastic? I love that. However, when I was doing the book, I was looking at one of the old paradox, parable things, one of the old stories. You make a very, very good life decision. You happen to save the life of the richest guy on the planet. He gives you a choice of reward because you immediately whip out a chessboard and you say, right, you've got a choice. You can put €1 on the first square, €2, €3, €4, and so by the 64th square, there will be 64 euros on the 64th square, and then the whole board will be covered in euros. That's one choice of reward. The other choice of reward, and I must get it right, is it a cent? 1/100 of a euro, is it a penny? It's a cent. The other choice is you put 1 cent on the first square. In fact, I'll write this up now. Beg pardon. The euros go 1, 2, 3, 4, but the cents double. Go 1, 2, 4, 8. So I'll put C for cent and I'll put that for euro, okay? And so obviously 1, 2, 3, 4. By the time you get here, there'll be 64 euros on that square, and 1, 2, 4, 8. That just keeps doubling, 16. But that's only in cents. Now you've probably heard this before, and you probably know the answer, but it's worth asking. Which one of these options will give you more money? Who thinks the euros will give you more money? Anybody want to put their hand up? Oh, you cynical people. And who thinks the cents are going to give you more money? It's quite a well-known puzzle. I mean, the cents does give you more money, and I thought I'll leave it there. But then I started doing the sums, and this is where it really, really takes off. Okay. I think I'll skip some of the maths to go with the euros. It's a triangle number. It's the 64th triangle number. But you can calculate the total number of euros on here. You do 64 multiplied by the next number, 65, and divide by 2. I can tell you that the answer, there will be 2,080 euros on the board by the time you've finished doing the board. With the cents, it's slightly more fun, and I hope you forgive me while I pick up this piece of paper here. We're going to keep going. 16, 32, 64, blah, 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 blah. Look at the squares. That's square number 8, that's square number 16. Square number 18 is the first interesting square. Well, they're all interesting in their own silly way. But by the time you get to square 18, the amount of money you have on the board up to square 18 will be 2,621 euros and 43 cents. By the time you get to square 18, you've already got more cents than you would have had if you covered it in euros. This is where it starts to go into space now. Square 21, on that square, there is over 1 million euros just on that square alone. Sorry, not euros, cents. Obviously, I'm used to doing this over in England. Our penny coins, if it was our penny coins, the height of coins on that square, if it was just one column of coins, would be about a mile or 1.6 kilometres high. We've only got to square 21. We're moving on. 21, that's square 29, that's square 37, that makes square 39. This is the next one. Oh, sorry, I ought to add somewhere around there. 9, 8, 7, 6, 5, 4, 3. Square 33. It's that one, I think. You know, all the banks crashing around the world, trillions of dollars and that. We reckon the amount of money on that square is enough to sort out the whole of the world's global markets and financial problems. But we've shot past there because the number of coins on square 39, if you pile them up in one tall, thin stack like that, would actually reach the moon. We then move on to square 48. We've just done the moon. Would anybody like to guess how high the pile of coins is on square 48? Yeah, it's actually 1.5 times the distance to the sun. But the real beauty is the number of coins, obviously, on square 64. You're about to see the saddest party piece ever played by a 53-year-old man. Here we go. The number of coins on square 64 is 92233678547758008. That is how many coins there are on square 64. 9 quintillion, 223 quadrillion, 372 trillion, 36 billion, 854 million, 775,808. If that doesn't get a round of applause, what does? And the beauty of it is, if you piled all those coins up in one little thin column like this, that column would be 1.5 light years high. I'd like to go back to my original question now. The guy can either give you the euros or he can give you the cents. Who thinks that they would actually be more comfortable with the euros because they understood that bit? Yeah, there you go. That is the chessboard paradox. Thank you very much. I hope you enjoyed that. I like the chessboard paradox. It's a cracker. A weird one. Right, I'm just going to have where's that nice lady introduce me? How am I doing for time there? Because once I get talking, I could be here for days.
Yeah, I think you're fine.
Okay, I want to show you another paradox. This is one that... I'll tell you, I'll do a little light-hearted trick first because it's a new toy. Brand new toy, this one. I only made this one for a book that hasn't come out yet. I need a volunteer. I don't know, I don't care who it is. I'm not looking at anybody in particular. Really? Hello, baby. This is okay. Nothing awful. I want you to think in your head of a number between 1 and 16. You see this weird piece of cardboard, okay? The number will either be the right way up or upside down. Is it upside down or the right way? Bless you, right way up. There's now another wee bit of cardboard here. Okay, is the number the right way up or is it upside down?
Upside down.
Upside down, okay. Don't change the number halfway through, otherwise it ruins the trick. I have kids that do that, okay. Is the number here, is it the right way up or is it upside down? Upside down, okay. So now is it the right way up?
Yes.
Can I just check, because I got it wrong this afternoon. It's the right way up there.
Yeah.
It's the right way up there.
Yeah.
And it's now the right way up there. Okay, there we go. You can see what's happening with the trick. Finally, we have this one here. Is it the right way up or is it lying on its side? Right way up, so that goes there. Okay, now the beauty is, can you actually face the room rather than face me? Can you shout out what number you're thinking of?
9.
Little round of applause, please. She hasn't seen it, there you go. You like that? Do you know, I knew that trick when I was, oh gosh, I must have been 10 or 11 years old, and I'd cut it out of a comic or something, and there I am trying to write this book 20 years later, and what? Ooh, you're suspicious, you lot. And gosh, it must have took me about 3 weeks to remember how to do the bits of cardboard, so I'm very glad it's worked here. Thank you for your help, my love. Right, this next one is, I say, I can't do this one in schools because, well, it's quite obvious why. I've got to get the right piece of paper. That's the one. Bonking. It's the paradox of bonking, ladies and gentlemen. Here we go. Right, I don't want to pick on any volunteers like that. But I want you to assume, just assume, for the sake of it makes the sums easier. There's a lot of making the sums easier in this one. I thought I'm going to start with a blank bit of paper. I want you to assume it's the year 2000 and you are 25 years old as an individual. Well, I'll look at Owen because he's sitting there. Owen, you're 25 years, bless you, 25 years old. So there you go. So that means 25 years prior to then, your parents had to get together and have a bonk to produce you. Yeah, okay, not difficult. But then, let's say generations reproduce once every 25 years. Back in around 1950, your grandparents got together to have 2 bonks to produce your parents. And going back another 25 years, 8 people, 4 bonks to okay, you can see where we're going with this, yeah? Right, year 2000, okay, 1975, 1950, 1925. Number of bonks to produce. Okay, 1, 2, 4, 1900, 8. Every time we go back 25 years, the number of bonks to produce Owen doubles. We're now going to go back to the year 0 AD. Okay, there are how many lots of 25 years? There are 80 lots of 25 years between there and 0 AD. The first one doesn't count because the one starts there. So in fact, the number of bonks it took to produce Owen that they had to have around the time of 0 AD is 2 to the power of 79, okay, because it keeps doubling, and that's how many lots of 25 years are there. 2 to the power of 79, let's go. I love big numbers, as you're going to find out. It's this number. Right, I should have put my glasses on, so I want to get it right. 909, 807, 314, 587, nearly there, 353088. That number is all one number, and that is a number of bonks it took to produce Owen in the year 0 AD, and that's just Owen. It took that many to produce her, and it took that many to produce him, and her, and him, and her. What is the population of the planet at the moment? It's over 6 billion. So let's get the zeros on. That's 6 will multiply, that becomes 36, and then we need to put another 9 zeros on. 1, 2, 3, 4, 5, 6, 7, 8, 9. To produce everybody on the planet. That is the number of bonks that happened around the birth of Christ to produce everybody on the planet. There's something even scarier going on here. I've got to get my facts right because otherwise people question this. Around the year of 0 AD, take this seriously, I've come a long way for this. She wants to go back. Around the year of 0 AD, there were only, and I've looked it up, about 100 million active adults on the planet. So if we divide this number by 100 million, I'm going to make that into 1, just makes life easier because I don't care. I move it back, that's 10, 100, so that's gone, there's a 1 there. Now we knock off a million, that's gone there. 14, whatever it is, all that number, that number, that number. That's how many bonks each person had to have around the life of Christ. It's also fair to assume that your number of working bonking days in your life, we're going to be generous here and say it's 100,000. You're going to be damn lucky to get them, but anyway, good luck. So if we divide this by 100,000, we take that 1 to 1, 2, that one goes to about there. We knock off another 1,000 like that. That's how many bonks a day you had to have. It's now fair to say there's about 100,000 seconds in the day. So if we move that one now there to there, we take off another 1,000, that's how many bonks per second everybody had to have around the life of Christ to produce the population of the earth. Ladies and gentlemen, I give you the paradox of the bonks. Thank you. How about that? Well, we love doing that one. We love doing that one. And I've no idea how long I'm supposed to talk. I'm enjoying it immensely, but I can see that you're sitting there looking longingly at the bar. There's one more wee thing I want to show you. After we have a break, I'm happy to take some questions or do 1 or 2 more tricks. But I would like to show you this because if you did maths at school, you're kind of familiar with this and that and the other. Okay, this is the sort of stuff. Do you remember about a year ago? They were all in Switzerland, all these people, and they're going to push a button on this thing called the Hadron Collider. And the Earth was going to suddenly disappear into a black hole, yeah. How many of you just looked at your cornflakes that morning and thought, this could be the last bowl I ever eat? I mean, how many of you were thinking that? And then the mathematicians said, no, it's safe, you'll be all right. What kind of sums is that? It's not like checking a till receipt, is it really? Hey, Earth disappear or not? So I want to give you an idea of just sort of some of the lateral thinking involved in maths. And let me just show you a little trick first. I get lots of emails from kids, and I ask people for the strangest number in maths. I'm on the Dave Fanning radio show tonight, and people voted for the saddest, most useless number in maths. This was the winner, 40, because it's the only number that has its letters in alphabetical order. Okay? But as soon as I started publishing on the internet the saddest and most pathetic numbers in maths, I was deluged. For this one, can you please count out loud how many lines I'm drawing on the board? Are you ready? Go! 1, 2, 3.
4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29.
Thank you. There you are. As soon as I put the facts on the net, I got emails from kids. One kid, little lad in Singapore, dear Mr. Poskitt, did you know that the number 29 is the only number you can write out using words in the English language, and the number of little lines it takes to form the letters is the same as the number itself? It's the sort of email you get and you think, that's today ruined. And you know, I sat down, I tried to do it, I couldn't do it. And I emailed the kid back, dear little kid in Singapore, get a life. I mean, well, no, I didn't. I mean, I said, I can't make it work. He emails me back rather patronisingly. He says, if you do it yourself, put 3 lines in the letter Y. If you just do that sort of Y, it won't work. If you do it yourself, I'm looking at you. All right, be honest with me. How many of you, secretly, at some other time, you might meet up with a friend and say, go on, put your hands up if you're big enough to admit that you might try that and show a friend. Thank you. A lot of people at the back haven't got their hands up. If people at the front think the people at the back are lying and they're desperate to show a friend but don't admit it, can we have a little, thought so. We'll look at them at the back, we're leaving. I got another email though from a kid, and it was an absolute belter. It said, dear Mr. Poskitt, what is your favourite net of a cube? Now, some of you think, what's a net of a cube? It's not a complicated thing. If you're not sure, this is a net of a cube. It's a shape with 6 squares like this, and you can fold it to make a cube. There we are. Can you see that? Little cubey. Now, the thing is, you can't just make any old pattern of 6 squares and fold it to make a cube, okay? Some of them won't. There are actually 11 different nets of a cube. And when I was talking about the Hadron Collider, I'm going to give you a slight insight now into the sort of brain required to work this kind of thing out. Is that going to tuck under there? Sometimes I do, sometimes I don't. Oh, please tuck under there. You're not going to tuck under there, are you? Come down a bit. Come down a bit. Come down a bit. There we go. Oh, I'll hold them up. I'll hold them up. I've got 3 of them here. I've got the green one. I've got an orange one. Oh, no, is that the pink one? And I've got an orange one. You can see I have these 3 different nets of a cube. I'm trying to hold them as separately as I possibly can. There we go. 2 of those will actually fold into a cube. 1 of them won't. Okay, ooh, a little bit of a mind twist here. I hope you can all see these clearly enough. What I'm going to ask you now, as a group, no individual embarrassment, okay, which of these 3 will not fold into a cube? Okay. Hands up if you think the green one will not make a cube. Ooh. Hands up if you think the orange one won't make a cube. Thank you. Thank you very much. Hands up if you think the pink one won't make a cube. Thanks at the back there. Thank you, the pink one. We'll start with the green one. Here we go. It's a strange looking sort of shape, but if you fold it like that, and then like that, and then like that, you get a nice little 6-sided. Sorry, Colette. Sorry, shut her hand up then. There we are. So the green one makes a cube. So it's between the orange and the pink. Just remind me again, please. Hands up who thinks the pink one will not make a cube. Hands up who thinks the orange one will not make a cube. I feel the heat coming off you people now, isn't it? Right. The pink one has no right to make a cube because there's no side bits to go on the end. Obviously, when you fold it like that, you get like a tube, and you get like another tube. But there is one last fold, and when you do that, the pink one actually bizarrely makes a cube. It shouldn't, it just does. There we go. And so that leaves the orange one here like this. And I think a lot of you managed to spot that as soon as you start folding it, you can't help but have 2 of the sides overlap. Okay, I'll do that again, I'll do it high up. As soon as you fold it, 2 of the sides overlap like that, then all you can do is that, and you've got an empty side. So if you thought it was the orange one, give yourself a little clap. Well done, I think a lot of you got that right, brilliant. But this goes back to this rather sad question that I had from a kid. Dear Mr. Poskitt, what is your favourite net of a cube? I've got one. Right, let me stand up here. They're coming to get me about this. It's obviously too radical. Let me stand up here where everybody can see it. It's disguised at the moment. The 2 little thin black lines, they're actually bits of cotton. I don't know if you can make those out. And it's got a little button dangling off it, so you're loving it already, aren't you? You are, aren't you? I'll let you. I'm going to pull the button, and this is why it's my favourite net of a cube. Be honest, ladies and gentlemen, it's the only one that puts itself together. A little round of applause for my favourite net of a cube. How's that then? I've no idea how long I've been talking for. I've enjoyed it immensely, but I think all of us could do with a drink now. So thank you for your attention for now. Thank you very much. There we are.